Okay, so here we go with number 6 from 2019. Twice differentiable, remember that means continuous, telling us g of 2 equals h of 2 equals 4, and that line is tangent to both those graphs at x equals 2, both the graph of g and the graph of h at x equals 2. So if that's the tangent line, then the slope of that line, 2/3, is the value of the derivative of both g and h at x equals 2. So there you go, there's the answer for part A. H prime of 2 is going to equal 2/3. Part B, here we have a of x and we want a prime of x and a prime of 2. Well, it's a product rule. A of x is 3x cubed times h of x. It's a product of two functions of x. So we take our first function, 3x cubed, times the derivative of the second, so times h prime, and then we take the derivative of the first function, 9x squared, times h. Now we evaluate that at 2. So x cubed is 8, 3 times 8 is 24, times h prime of 2, plus x squared is 4, times 9 is 36, times h of 2. H prime of 2, we said in part A, was 2/3, so 24 times 2/3, plus 36 times 4. There's our 16 plus 144 is 160. And this was, yes, expected to be done without a calculator, but you guys will have a calculator to use. So there's part B. Now part C. H satisfies h of x equals that. For x not equal to 2, and we know that the limit as x approaches h of x approaches 2 of h of x can be evaluated using L'Hopital's rule. And we can use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2 and show why. Well, since these functions are twice differentiable, that means they're continuous, which is going to mean the limit as x approaches 2 of h of x equals h of 2, which was defined to be 4. But we will get to that. So limit as x approaches 2 of h of x is limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed. Now, since we have to use L'Hopital's, let's see. At x equals 2, x squared minus 4 equals 0. So that means 1 minus f of 2 cubed has to equal 0 if we're going to use L'Hopital's. And solving that, that gives us f of 2 equals 1. So now to use L'Hopital's, limit as x approaches 2, we take the derivative of the top, 2x, over the derivative of the bottom. Another reason why this is a really good question, because now you have to use the chain rule in its f of x form. So derivative of the outside, -3, keep the inside, times f of x squared, times the derivative of the inside, times f prime of x. And here's where we use the fact that since the function is continuous, the limit value equals the function value. So we set that equal to 4, subbing in our known values. We just found out that f of 2 equals 1, and we're going to solve now for f prime of 2. Cross multiply, do some algebra, we wind up getting -3 times f prime of 2 is equal to 1, which gives us f prime of 2 is equal to -1/3. So that, in my mind, is a great type of question they could use to test a whole lot of concepts. Part D, since k is between g and h, that means k of 2 has to be between g of 2 and h of 2, so that basically means k of 2 has to equal 4. And then by the squeeze theorem, the limit as x approaches 2 of k of x also has to equal 4, since the limit as x approaches 2 of g of 2 and h of 2 will equal 4 because they are continuous. So that means since the limit as x approaches 2 of k of x, which is 4, is equal to k of 2, which is 4, k is also continuous at x equals 2 by the definition of continuity. Another great question testing multiple concepts.